Okay, we're going through the study guide for the test. Answer to problem number 1 is C. Answer to number 2 is B. I'm now in Maple putting in something to make it look to see whether or not I am correct. All right, let's see, assistance. Plot builder. R equals 5 sine theta. Okay. And where is the polar setting? Cartesian, there we go. We want elliptical, bipolar, no, polar. Polar, plot. A circle? I don't think so. That's right. I don't think that's right. Do it again. Tools, assistants, plot builder. R equals 5 times sine 4 times theta except. Okay. Theta. Wait a minute. Theta's got to go 0 to 360. 0 to 360. Unless we have to be in radians. Cartesian, polar, preview, huh? Rows now. Preview.
Looks like a rose.
Yeah, it does look like a rose. You got a point.
Okay. Come on, not coming up on Maple. All right, so we don't want 360. We want 90. Probably 90. No. Oh, that's the problem. No, horizontal. This is the. This isn't horizontal and vertical anymore because we're in polar coordinate system. How come I can't change these guys to something other than that? Labels, line. Line, symbol, color. Advanced settings, axes. Box, frame, none. Advanced settings. Tick marks, alignment, linear. Why can't I be... Why, if I sent this to there, grid size, style, axes, Guess we'll have to do it manually. Fill regions. Why can't I set this to command? What does command mean? Back. Oh, there we go. Right here. Plot. Plot. Simple. That guy. We got to change that guy there. Probably. 90. Preview. Alright, so implicit three-dimensional plot. Plot. Edit functions. Alright, tools, assistants. Plot builder. Why can't I change that? 3D implicit plot. R. R is equal to 4 sine theta. But R isn't changing. 5 sine 4 theta. R is not changing. R is something that's being calculated. Implicit 2D plot. Polar. Yeah. All right, well, we can't make maple work, so we'll just have to go with my answer. All right, on to number 3. Well, if we go, we move back to number 2. If R were, as the sine theta changes, so theta is going to go from 0, sine theta is going to do that, right? So I'm going to go at 90 degrees, I'm going to be out at 5. At 100 and at minus 90, I'm going to be at minus 5. I'm going to be in there. If I were to put a 4 theta there, then I would get to 1 earlier, and I'd get to 1 later, and I'd get to another 1 over there, and I'd have a total of 8 of them. So that is what would happen. And why Maple isn't allowing me to do that, I have no idea. All right, back to what we're doing. Did I put 3 up? I didn't. Moving on to 3. Oh. Uh-oh. X squared y squared minus 4y minus 12y is equal to 0. Change the polar. All right. my x squared plus y squared becomes an r squared minus 4 times x. Let's see, x over r is cosine theta. So this is going to be r cosine theta minus 12 r sine theta is equal to 0. Okay, the only one that's r squared is this one, and if I put those other guys on the other side of the equation, it has to be d. Well, that was pretty simple, seeing that there's only one r. Wrong. No, that's not the issue. The issue is I've got an r here, an r there, and 2 r's here. So I become r is equal to 4 cosine theta plus 12 sine theta. And that's C. Okay. So I was okated there, and then I fubbed it when I went down. Number 4. Now you know there's only 2 chapters on this test. Find the equation of a circle in standard form with the radius of that. Okay, so the circle is going to be in the form x minus 7 squared plus y plus 8 squared plus r squared, which is 100. Looks like A to me. Yeah, A. So the equation is x minus h squared plus y minus k squared is equal to r squared, where h, k is the center. So that'd be x minus 7, x minus a minus 8, making it plus 8, and r squared. All right. Am I going to run out of time? Should I speed up some? Well, I sped up so much that I didn't get what I wanted. Number 5. The height of a projectile is fired. The height of a projectile fired vertically upward is given by that. Initial velocity is that. Find the maximum height. Find the maximum height. Okay, so we're going to take the first derivative, y prime is equal to 680 minus 32t. We're going to set that equal to 0 and have that t is equal to 680 minus 680 divided by minus 32. And because I forgot my calculator, I'll have to use a different one. So 680 divided by 32, 21 and a quarter, 21 and 1/4 seconds. So when I take the first derivative of the position function, I'm finding the maximum. When I set it equal to 0, that gives me the maximum. So the maximum height is going to occur at t equal to 21 and a quarter. Okay, so the maximum height is going to be f at 21 and a quarter, because that's my position function. Okay, so that's going to be 680 times 21 and a quarter minus 16 times 21 1/4 squared. Alright, so I've got 16 times 21.25 squared with a minus sign plus 680 times 21 1/4 equals. So my maximum height is going to be 7225, and now, oh, look at that, there it is, sitting right there, D. So I would not do that. Oh, no, it says maximum height in feet, so I don't necessarily have to have my units there because I'm told that it is in feet. Okay, so I would go with D. Yeah, that's how I would do this as a tech math problem. Now I would do it differently as a physics problem. I wouldn't do it that way in my physics class, but that's how I would do it in my Tech Math 3 class. Find the time that I get to my max height by looking at solving the first derivative at t, setting it equal to 0, solving for t. Okay. Now we're better off. Now we're to the short answer ones where I can pick any answer I want. And it'll be perfectly okay because there won't be anything there saying there's something different, right? Find the equation of a parabola. Okay, vertex is there. The directric is at y equals 6. Y equals minus 6. So it's going to do something like that. Okay, so we remember that y is equal to 4px squared, right? Is that the equation we remember? So the answer would be y is equal to minus 24x squared. Oh, no. No. Because it's the p comes from the focus. So that would be, the focus would be at up there at 0, 6 would be the focus. So 4px squared, where p comes from where the focus is. Otherwise, I'd be pointed the wrong way. Okay, that was easy. Of course, I missed it, but other than that, good recovery. All right, so I want a circle in standard form, center there, passing through there. Okay, so that's not a bother. So general form is x minus h squared plus y minus k squared is equal to r squared. We know the center, so we got x minus 7 squared plus y minus 3 squared. And now if the problem would have given us r, we would have been done already, but they didn't. So how are we going to come up with r? Okay, so I make a coordinate axes, and my center is at 7, 3, and I'm passing through a point 6, minus 2. Okay, so I want to know how far that is. Okay, so that's going to be, r is going to be square root of the 1 squared plus 5 squared square root of 26, square it, and that'd be a 26, and that would be my final answer. Okay, questions? Yep. Okay. So I go and I look at I draw an XY plane, and my center is at 7, 3. So I come out to 7, 3. There's my center. And it passes through a point 6, minus 2. 6 minus 2. So that means my radius has to be that. Say, what's the change in x? X only went 1. So r has to be square root of 1 squared. And I went from 3 to minus 2, so that's a 5. Plus 5 squared equals square root of 26. And the equation needs a square root of 26 squared, giving me 26. And this side of the room shaking their head yes, like it's right. Something's wrong with that problem.
I had the same question, but I figured it out in my head shortly after.
Yeah, yeah. If you draw a pretty enough picture, it shouldn't be that hard.
Don't feel dumb, Joel, because I was dumb for a second.
Yeah. Thank you for explaining.
Yeah, you just have to have a better than normal picture sometimes. For the problem below, find the derivative. Okay, well, it looks like I'm in the form y is equal to uv, so I'm going to say that y prime is u prime v plus v prime u. Okay, so that's what I'm going to do. So I'll change colors and write down the answer. Y is equal to y prime 8x to the 7th times 3x squared plus 5x minus 7 plus x to the 8th times 6x plus 5. And at that point I would call myself done. I wouldn't try to combine like terms. I wouldn't do anything. I just say done, move on. Okay?
You said you wouldn't try to combine them?
Nope, I wouldn't. Nope. If it said find the derivative and simplify, then I might think I should simplify it.
Okay.
But it didn't tell me to simplify it, so why should I bother?
Okay.
If I wanted the derivative at 20 different points right now, I'd put it in a spreadsheet and find it, right? I wouldn't go and put it in my calculator one at a time looking for it. Yeah, exactly. All right, now we're doing 9. All right, so if I put 5 in there, I'm dividing by 5, I'm dividing by 0, and the top guy is 0. So obviously, I have to find the limit of that. I would use something from a chapter that comes after this. I would use L'Hopital's rule. And that's misspelled really bad. The L and the H are correct. L'Hopital's rule, and say the limit as x approaches 5 of x squared minus 25 over x minus 5 is equal to the limit as x approaches 5 of 2x over 1, and say that that's 10. Now, in this particular, because the limit of a function divided by another function is equal to the limit of the derivative of the top divided by the derivative of the bottom. So that's what L'Hopital's rule said. But I took the derivative of x squared minus 25. Saved by the bell. Now, before we do that, we should probably go. So in the chapter that you're in, you would do that. You'd factor the top and the x plus 5, x minus 5, get rid of the x minus 5 and put in a 5 and say 5 plus 5 is 10. That's not how I would do the problem because I know L'Hopital's rule, but that's the way you would do the problem because you wouldn't think of doing the derivative of top and bottom.
No, we don't.
Yeah, you get the same answer either way, so.
Might try that.
Yeah, that's a good idea, try it. Okay, well, this is the same type of problem over again. We're going to infinity, so we got infinity top and bottom. So if I were to use L'Hopital's rule on this, I would say that this is 8x over 16x is equal to limit x goes to infinity of 8 over 16, which is going to be 1/2. So that's how I'd use L'Hopital's rule to do it. And if I wasn't doing that, I would say this is limit x goes to infinity 4x squared minus 7 divided by 8x squared plus 5. And then I'd multiply top and bottom by 1 over x squared. Because if I do that, that's just 1. And I'd get limit x goes to infinity 4 minus 7 over x squared divided by 8 plus 5 over x squared. And then I'd say this guy goes to 0, that guy goes to 0, and I have 4 over 8, which is 1/2. So I would do it that way. If I was going to do it with algebra, not with a calculus approach.
And how come the 7 over x squared and the 5 over x squared go to 0?
Well, as we're going to go and open up a spreadsheet for that. Okay, so I'm going to have I've got some equation, and it's going to be 5 divided by A1. Okay, 5 divided by A1. Copy, paste. All right. So I divide by 1, I get a 5. I divide by 10, I get a 0.5. I divide by 100, by 100,000, by lots and lots and lots and lots and lots. Am I going towards 0 or not? Am I getting closer to 0?
Yeah.
So as x gets bigger and bigger, and it's x squared, right? I'm not even squaring it. I'm going to have to go and square it. So then if I square it, I'm going to get to 0 quicker. Well, that's even better. And I'm even getting the 0 quicker that way. So does that explain the situation?
Okay.
Yeah, as when I'm dividing by something that's getting very, very, very large, I'm getting closer to 0. Yeah. So if it goes to infinity, it will be 0, right?
Yeah.
Exactly. And so that's what you're trying to do. You're trying to get something divided by the x that's going. You don't want to divide by 0. So if this was saying x goes to 0 of this, then you wouldn't want to do that because that wouldn't help you out any. Okay. What was that, 10? Only one more? Hope it's easy. It is.
Then you'll have to go put it in sale, not sale, but maybe right?
Well, no, it's too easy. Find all the derivatives. No, it doesn't even say that. It just says find the derivative. All right, so y prime equals 8x cubed minus 6x. And I'm done. Oh, Dun City. Now, you don't remember how to take a derivative? There's the back of your book. There are very few you have. I mean, your toolbox of taking derivatives are very small. But other than that, everything should be pretty much that easy. Is that pretty easy? Only because I was doing it? Yeah. That's the problem. It's only because I was doing it. All right. Well, maybe I will. Yeah, I'll put that. I'll put it on sale so you can. Or not sale. I'll put it on the website so you can have it. And when I make up the test, I can't have any more than 11 questions, and they all have to be that easy, right?
Yes.
So there can't be anything harder than anything that we had.
We put the
And
Parabola equations, circle equations on
if you ask for them, yeah.
What if we came in and started writing equations on the board?
Well, you don't want them there because now that would confuse you because that might not be used on the test. You only want the ones on the test on the board.
Yeah, that's true.
Yeah. And maybe I'll bring some polar coordinate paper because clearly if I had polar coordinate paper that might help too, right?
Yes, of course.
Just for argument's sake, the second prime of that, would that be 24x squared?
Y double prime 24x squared. Y triple prime 48x. Y the fourth derivative 48. All other ones 0.
Right.
So, if finding the derivative finds the slope of the point on a line, what
Yeah.
is the
Second derivative. The second derivative would be the curvature of the line.
Okay.
So here we got some curve like that. So the first derivative is the slope at any particular point on the line, and the second derivative is the curvature. And normally what you do is you find out when it changes from positive to negative. So I have concave down and concave up. So I'm looking for concave down, concave up on my function. So this is I'm concave down, I'm pointing down, concave up, I'm going up. If it is a position function, so I have some position function, then the first derivative is velocity and the second derivative is acceleration. So it could have some physical reality and not just be a function of not be some graph. Okay?